Hello, everybody. My name is Roberto Fodera. This is my project presentation for the Machine Learning Foundations for Product Management course. Its goal is to describe you my approach to fulfill the requested task. Let's start by spending some words about the starting point, respectively, with the problem that has to be solved. We have received data. That means data were available for the following features. These are 4 features: temperature, vacuum, pressure, humidity, and we have one target output, which is the electrical energy. Generally, in this presentation, the problem that have to be solved are basically the two following problems: to define a machine learning algorithm to predict PE and to select an appropriate output metric to evaluate performance. The first step to achieve the wished outputs was to define the right machine learning approach and also to define the appropriate output metric to evaluate performance. For the machine learning approach, based on the data available, we can very confidently assume that there is a linear relationship between features and target. Therefore, a supervised learning algorithm based on a linear regression may be the appropriate choice. Further, for the output metric to evaluate performance, I will define the following 3 metrics. So mainly I will work with R-square, but I also calculate MSE and MAE to additionally support the right decision. The next step was to the determination of the possible features in order to be used in the future model. As we said before, we defined that linear regression is the right approach. There are 2 linear regressions which can be used: a simple linear regression and a multiple linear regression. Since there are more than one features data available, a model based on a multiple linear regression may be the right choice. Anyway, in order to evaluate the importance of the single feature for the output results, a simple linear regression for each feature was executed and R-square calculated below the summary of the results. As you can see, for the AT and V, we have very high square value. Normally, square value higher than 0.7 are already defined as very good. Then we have for EP and R each are low values, and therefore I define them as low or low to middle importance. The most important points here is, as defined in my conclusion, it is that 2 parameters, that means temperature and vacuum, are the most dominant features, and it can already be assumed that only with these 2 features the model will already reach very good results. Now the next step was to define models and their coefficients. As said before, and based on the results on the previous slide, the following feature combination will be further examined: AT and V, model 1, model 2, AT and V and pressure, and model 3, AT and V and AP and relative humidity. The analysis has been done by using Excel. The data for the analysis has been divided as following: first, training set around 80% of the data, then a validation set around 10% of the data, and finally a test set around another 10% of the data. For all these combination, a multiple regression evaluation with the training set has been executed and defined the coefficients of each model. In the table, you can see here are all values and coefficients for the different combination and for the different features. Next, we had to compare the three defined models. For this, a correlation of the models was done by using a validation set. First, you can see the three model combination, then the model defined, so number 1, number 2, and number 3. And then I calculated for each model S-square, MSE, and MAE. As you can see, generally, all three models had very good results. Due to the little differences, all three models may be used. The best is clearly model number 3 with all 4 features. And therefore, it will be used as the final model for the test set. The final step was to check the performance of the final model. As said before, I choose the last model with all 4 features as my final model. And here I calculated the S-square, MSE, and MAE with the test sets. Basically, the results are in line with the metrics defined already before with the validation set. Thank you for your patience and wish you a nice day.